So now have a look at today's daily question. Question 3075. Maximum happiness of selected children. Medium. In a given array, happiness of length n and a positive integer k. There are n children standing in a queue, where the ith children has happiness value I. You want to select k children from the n children in k turns, and k is less or equal than n. If k is greater than n, it is not it is meaningless, because the part more than n cannot select any children, so k is less or equal than n. The constraints. In each turn, when you select the children, the happiness value of all the children that are not being selected till now decreases by 1. Note that the happiness value cannot become negative and gets decremented only if it is positive. Return the maximum sum of happiness values of the selected children. You can achieve by selecting k children. Let's draw it. Let's draw it. 1, 2, 3, and the k equal to 2. We can select 2 children. First, we select 3 because it is the largest. Then 1 become 0 and 2 become 1. Second, we select 1. So the return value is 3 plus 1 equals 4. Output is 4. Explanation. We can pick 2 children in the following way. Pick the children with the happiness value equals 3. The happiness value of the remaining children becomes 0, 1. Second, pick the children with the happiness value equals 1. The happiness value of the remaining children becomes 0. No third. So the last should don't need to be calculated. The sum of the happiness value of the selected children is 3 plus 1, 4. Example 2. Input happiness 1, 1, 1, 1. K equals 2. So you can only select one of them only one time. The second time, every remaining becomes 0. So the output is 1. We can pick 2 children in the following way. Pick any children with the happiness value equals 1. The happiness value of the remaining children becomes 0, 0, 0. So no matter what you pick, the return value will be the only children you pick at the first turn. Then the return value is output is 1. And example 3. Input happiness equals 2, 3, 4, 5. Example 2. 1, 1, 1, 1. You can only select 1, 1, 1. You can only select one of the children, and the happiness value is 1. And then every other children become 0. So you don't need to select anything. The output is 1. After you select, all the value become 0. So example 3, 2, 3, 4, 5, and the k equals 1. So which one should we choose? Obviously we should choose 5. So the output is 5. We don't need to calculate anything because after we choose, everything is done. it's not so hard. Every time when you choose the largest, so we need to sort the array. Yeah, let's think thoroughly. First, we need to sort the happiness, sort the array, and then from the first such like this. After we sort, we get this 5, 4, 3, 2. Suppose the key is very large. Suppose then the first time we choose this, and we choose this. We choose 5. The second time we choose the second and sub 1. It is second sub 1. And the third time we choose the third one. It is 3 minus 2. The value is 1. The first time we choose the first one, and it is 2 minus 3. So this is minus 1. And the question has given that it is not only if it is positive. So this is after 2 decrease it becomes 0. Yeah. So this should not be. This should be omitted. Just 0. Just 0. And this is 1. And this is 3. This is 5. So suppose the key is 4. Suppose the key is 4. Then the return value should be 5 plus 3 plus 1 plus 0. It is 0, not minus 1. So the output should be 9. Yeah, 9. It is easy. First we sort, then we no. For every this is I equals 0. Yes. For every digit, we just sub it by the I. If it is less than 0, then we can break, because all the children afterwards, all the digits afterwards are less than the increasing I. So let's draw it. This is easy. It solved in this way. The key, it is guaranteed that k is less or equal than the happiness size, and the constraints n is the happiness length. It is less or equal than 2 plus 10 to the power of 5. Happiness I is positive and not that large, but very large. Yeah. So the return value is long, not an integer. If it is greater than 0, then we just sub. Just sub happiness I sub I, then it is remain. Else we break. As we break out, then we return the return value. Everything works. I wonder why this is a medium. It should be easy, right? And the acceptance rate is very high. Oh, it is very slow. This question can be solved using a top key solution. Because time complexity, or we can save the data in a priority queue. Yeah. Top key question. Time complexity. Oh, n log n. This is the n log n solution because we need to sort the whole part of the happiness, and if the key is very small and the happiness size is very large, this algorithm can be very slow because we want to sort because the time complexity is n log n, and the space complexity. We didn't use any extra memory, so we sort the happiness just in place. So the memory cost is O1. Space complexity is O1. Yeah. I have got a fever. Hope you guys take care of yourself and to be healthy. Not like me. This question can also be solved by a priority queue. Let's have a try. We come back here. Because when the key, suppose the happiness size is very large, very large. Yeah, this size, but the key is very small. Imagine that the key is 1. And the happiness is very large. What should we do? We just get the largest value out of the 10 to the power of 8. Only one element. We can use ON solution, not n log n, right? So if the k equals to 2, then we get 2 element and still ON nearly. Okay, it is in actual fact it's an okay solution. Yeah. So we just use a priority queue. Enter. This is the priority queue. May need to meet with we should use a large priority queue or a small priority queue. The value should be, I cannot remember, it is the large priority queue set. So just implement it into the queue. if it is greater than then K we should pop. Then we get the priority queue. Every time we pop the small element out and leave the large element, then after all of this, what should we do? We should add up it. Still, y now q y q is not empty. And we add it to current IT, and we need a decrease. The last elements may not be added, so we need to check if a count is greater than we set the decrease to be k, right? To be k minus 1, yeah, because the last element is 0. IT, add IT to minus decrease. Yes. Then we just return the IT. This should work. Let's have a look. Oh, what's wrong? Great. Oh, got some spare arrow. Greater. What? Priority queue. Yes, sequential type. Integer, vector integer, like this. Current. Not at the top. Top. The interface is just like the STTQ. What's wrong? Gives the 2, but output 3. Why? Did we put output 1 and 2? Right? Which is still less. And STLS can be omitted. Oh, what's wrong? We select a 2 element, and the output is 2. So, not less. Priority queue. Priority queue. You less or equal. Should we use this? Why the output is 1? Why the output is 1? It's greater, right? But the output is What output is 3? Why? Oh, the k should be the decrease should be decreased step by step. Yeah. Then everything works. This is the OK solution. K steps. We only get. Oh, still very slow. Why? Or we should use a binary sort to get the OK element. Why is it so slow? This is the OK solution, right? Because every time we push it nk, O max nk. Yeah. And space, we need extra space. Is there any better solution? Oh, sort. This is what I do, right? Why is it here? Is this solution very k equals 0? Oh. Why is this solution much faster than my solution? The sort with the greater is much faster. Oh, let's have a look at some other solution. They all sorted. This is somewhat update. Oh, still sorted. More or less the same, right? But they're all very fast. But my solution is slow. What's wrong? I just want to know what's wrong. What's wrong? Why my sort so slow? So use greater. Okay. So let's get back to my first submit and change it to greater. Maybe it could save many. Could be faster. So this is very fast. Oh, because this break slowed down. Oh, this is much faster, almost 10 times faster than the prior. Okay, so remember to sort not use R beginning and, but use greater. Greater is much faster than reverse. Or if we just reverse, so could it be faster? So this be faster? Can this? Oh, this is faster. What's wrong? Why is this so fast? I don't understand. Okay, so this is today's daily question. There may be some not so accurate, but we still need to sort it. Use greater. Use greater. I think this is better, and this can be commented. Yeah. So submit again. Oh. Okay. So this is today's question. Somewhat easy. You just draw it clearly, and you will get get a triangle like this. This is a triangle, and a triangle like this. This is another triangle. Yeah. This is another triangle. This triangle is increasing, and this triangle is decreasing. You should use this value to sum this value. If it is greater than 0, then we just add it to now return. Else we don't need to do anything. Else we just break. All the other part can be deleted, can be omitted. We don't need to consider them. Just the first key elements. And when we come to some 0 or negative, we just break. This is the picture, yeah, that can be understand and it can be understood easily, and the acceptance rate is very high. So thanks very much for today's daily question.